Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about the evolution of learning to rank. This episode is based on a tech blog titled From RankNet to LambdaRank, Leveraging XGBoost for Enhanced Ranking Models, written by the OLX engineering team. You can find the link in this episode's description. Throughout this episode, we will explore this topic from both business and technical angles. Now, let's dive in. On the business side, let's take a look at the problem to be solved. OLX Group is one of the world's leading online classified platforms. They operate in over 30 countries, mostly in Europe and South Africa. They have around 11,000 employees and serve more than 300 million monthly active users. In 2022, they reported nearly $3 billion in revenue. Now, think about the last time you used a marketplace like OLX to find a used car, a second-hand sofa, or even a job. You type in keywords and get thousands of results. As a business, OLX faces a massive challenge, which is relevance. If a user has to scroll through pages of irrelevant listings to find what they want, they'll probably leave. But it is not just about the matching item, it is also about the ordering of the listing. In the marketplace world, people care about liquidity, which is connecting buyers and sellers as quickly as possible. If the most relevant, high-quality ads are buried at the bottom, sellers miss out on leads and buyers can't find what they need. That hurts both user experience and the business performance like retention or ad revenue. The company needed a way to dynamically rank millions of ads, ensuring that the best ones, which is the listings most likely to lead to successful transactions, would appear right at the top. This is a classic learning to rank problem, and it's the engine that powers the company's user experience for millions of people every day. Now that we've understood the business problem, let's shift gear and look at how the team tackled this challenge. To understand where we are today, we need to revisit a few key ranking algorithms. The blog walks us through the team's journey that starts with RankNet and evolves into LambdaRank. Those are two major milestones in this space. Let's start with the basics. In traditional machine learning world, we often deal with two problems: classification or regression. Classification is like, is this email spam or not? Regression is like, how much price is this house worth? But the ranking is different. Instead of predicting a label or value, the goal is to order items by relevance. Is ad A more relevant than ad B? That's where RankNet comes in. This algorithm was introduced by Microsoft Research. It treats ranking as a pairwise comparison problem. Instead of looking at one ad at a time, it evaluates pairs and learns which one should rank higher. A neural network generates a score for each ad, and a sigmoid function converts score differences into probabilities that one should be ranked above the other. The model is trained using cross-entropy laws and minimizes any inversions, where less relevant ads appear above more relevant ones. After we discussed about how RankNet works, it has a drawback. This algorithm treats all ranking mistakes equally. In real-world systems, the top of the list matters most. For example, if the 100th and 110th items swap, no one will notice that. If the first and the 10th items swap, that's a big problem. RankNet doesn't distinguish between those two errors, which limits its usefulness in production systems like search or recommendations. Understand the limitations, that's where LambdaRank comes in. Instead of defining a single mathematical loss for the entire list, LambdaRank directly adjusts the gradients, which is the directions the model uses to update itself. Each data point gets a lambda, which represents how much it should move up or down the list. These lambdas are weighted by how much swapping two items would change a real evaluation metric. The metric is called normalized discount cumulative gain. The normalized discount cumulative gain gives higher credits for placing relevant items near the top. LambdaRank scales each gradient by the change in this metric that would result from correcting that pair's order. In other words, it focuses learning where it matters most, on improving the top-ranked results. This simple idea made LambdaRank far more practical. By making the model position-aware, it bridged the gap between theoretical ranking algorithms and real-world systems. This simple idea made LambdaRank far more practical. By making this model position-aware, it bridged the gap between theoretical ranking algorithms and real-world systems. And this laying out the groundwork for later models that power many large-scale recommendations and as ranking engines. Building on top of the foundation of RankNet and LambdaRank, the team adopted these ranking principles to their massive marketplace, where each search session involves thousands of listings competing for visibility. To train their model, they grouped listings by sessions or queries, analyzing which ads users interacted with and which they ignored. This structure lets the model learn real-world preferences across categories. For instance, mileage might be crucial when ranking cars, while for furniture, location proximity or delivery options could matter more. To handle this complexity at scale, the team used XGBoost ranking objective, which extends the idea from LambdaRank. Instead of predicting click probabilities, it optimizes for the quality of the entire ranked list, emphasizing improvements at the top of search results where they matter most. With hundreds of features incorporated, the boosted trees capture nonlinear relationships, and enabling the team to surface the most relevant listings for each unique context effectively and at scale. Now that we've discussed both the business problem and the technical solution, let's wrap it up. In this episode, we explored how OLX evolved its ranking algorithms, from the pairwise logic of RankNet to the metric-optimized design of LambdaRank. This is to ensure users find what they are looking for quickly and efficiently. We saw how moving from simple classification to learning to rank helps business prioritize user attention where it matters most. If you like the content of this episode, please subscribe to the channel. Give me a 5-star review and leave a comment. Your feedback is very appreciated, and I'll see you next week.